Okay, 80, let's see, 87. Kind of a long one. It says a package of mass is released from rest at a warehouse loading dock and slides down a 3-meter high frictionless chute to a waiting truck. Unfortunately, the truck driver went on a break without having removed the previous package of mass 2M from the bottom of the chute as shown in the figure. There's two parts to this question. The first says, suppose the packages stick together. What is their common speed after the collision? So we can, according to the conservation of mechanical energy, the potential energy at the top of the chute equals the kinetic energy at the bottom. So we can rewrite this as the mass times gravity times the height equals 1/2 the mass times the initial velocity squared, which is what U stands for. So, okay, will disappear again. Okay, so we need to make the potential energy of the package at the top of the chute equal with the kinetic energy at the bottom. So we can do that by doing mass of the package. G is the acceleration due to gravity, and H is the height. And it's going to be important to distinguish the mass 1 from mass 2 later on, so that's why I put an M1 there. And so then we can, rewrite the equation in terms of the velocity of the package at the end of the chute. And so the velocity at the end of the chute, like we said, was U1. We isolate that. We can rewrite this to say the square root of 2 times gravity times the height. And then we can substitute what we know, which we know is gravity, which is 9.8. Oops. And our height, which is 3. And that's going to equal square root of 58, which equals 58.8, which equals 7.67 meters per second. Okay, so now, the velocity of the package at the end of the chute is the speed which the package hits the package on the truck. And then they get attached together in this first scenario. So we're going to write M1, the mass times the initial velocity plus mass 2 times the velocity 2 of the second package equals the mass plus the mass again times the velocity of the final of the 2. So we want to find the final velocity of the 2, so we're going to have to isolate that. We can do that. And that's going to look like this. Mm-hmm. 1 plus 2m. Okay. So notice how he plugged in 0 for the final velocity because it's not moving anymore. So if we simplify this down, it's going to be 3m1. That's just going to be over 2m. Oh, no. 3. There we go. Okay. Now we can substitute our known velocity for the first package, which we know again to be 7.67. So the final velocity is going to, let's see, bring that up here. Going to equal 2.56 meters per second. And there's the answer. The common speed of the package on truck and package released after collision is 2.56 meters per second. That's the first part. The second part was suppose the collision between the packages is perfectly elastic. To what height does the package of mass and m rebound? Okay. Let's redo this here. Okay, so according to the momentum in elastic conditions, the final velocity of a package f of f is going to equal the mass of first times minus the mass of the second times the velocity of the first plus 2 times the mass of the second times the velocity of the second, all over the mass of the first plus the mass of the second. So we can substitute 2 times the mass of the 1 for the mass of 2, and 0 obviously for the final velocity. And so we can rewrite this as m1 minus 2m1 times the velocity plus 2 times 2 mass of the 1 times 0 all over the mass of the first one plus 2 times the mass of the first one, and that equals negative u over 3. There's a quick simplification. And then we can substitute, I should have erased that answer. Okay. Substitute 7 point. I believe it was 7.59 meters over second squared divided by 3 equals so we're going to substitute 7.59 for the velocity of the first to find the velocity of f of 1, and then divide that by 3. It's going to give us 2.53. And then, so the potential energy of the package at the final height reached after collision is equal to the kinetic energy of the package immediately after collision. So we need to 1/2 the mass of the first times the velocity of the second, the final velocity. It's going to equal the mass of the first times gravity times height. Then we're going to rewrite this in terms of height of the package after the collision. It's going to be h of f equals v squared f1 over 2g. I'm going to substitute this for this. It's going to be 0.53 squared over 2, and our mass was our gravity 9.8. That's going to equal That's going to equal 6.4 divided by 19.6 equals 0.32 meters. 0.32 meters. And then we times that by, let's look at our, so yeah, 3.2 meters. 0.32 meters is our answer.